Hello, guys. Thank you for joining me today. Our meeting today is talking about planning in the course of construction planning and scheduling. Last meeting, we started talking about planning in general. In general, the definition of project planning means the development of a workable program of operations to accomplish established objectives when put into actions. To be more specific, the construction project planning means the process of identifying the steps required to build a structure. In a very simple word, we need to plan to start our project. Planning means we have to organize, we have to create sequences, how we will construct the project. It involves defining what actions need to be completed, creating an ordered timeline of events, staffing the project, and determining the necessary materials and equipment. Make sure the planning will define when I need to rent an excavator to start your excavation. For example, when I need to rent a concrete pump to pour concrete. That makes sense? So after 2 weeks, after 3 weeks, whatever. So we need to define what actions needed to be completed. A well-crafted construction plan is important. We have to put a very excellent and smart plan. Is important to keep the project on schedule and within the budget. So it's very important, the top target, the top purpose of planning to keep the project on schedule. Also to keep the project within the budget. So we are talking about time and we are talking about cost of the project. It can also help ensure the overall quality of the project meets your client's standards. Finally, having a construction plan can increase your team's productivity and efficiency by streamlining communication. So, excellent, good construction plan means success. Also, we discussed who needs construction planning. We have different parties involved in the project, in the construction project. So all of them need planning. The owner of the project needs planning. The designer of the project needs planning. The contractor needs planning. So all of them, all parties involved in the construction projects will need planning, not only one person or one party. Why do we need construction planning? It's a good question. We need to do plan for estimating how much the cost of this project, timely completion, when this project will be done, communication and coordination. We need to communicate when we need to deliver material like sand, like cement, like wood, any material, any resources in the project. We need to communicate, we need to coordinate when we need to deliver these resources. Resources management, control. We have to make sure we are within the budget and within the time. Optimization. So keep in your mind, planning increases the probability of project success. Who plans? Who is the person that will plan for the project? The person who is familiar and has more experience with the type of field and have knowledge of construction methods. So it's very important to start the plan of a project. You should have a good experience, who have ability to visualize work elements and interdependency. That makes sense? So we will try our best to learn something in this course and to gain some experience how to construct or how to start planning of a project. We discussed before what is the meaning of construction project activities. Activity, this is a single discrete work step in the total project. It needs time, cost, and resources. For example, the construction phase involves site preparation, excavation, foundation, framing, masonry work, roofing, interior finishes, and exterior finishes. All of these are considered activities. And each one can be considered a title, and we have many activities under this title. For example, foundation. Foundation means pouring concrete. Pouring concrete means we have reinforcement. We have formwork. We have pouring concrete itself. So we can divide it to different activities, or we can assume the foundation is one activity. Does that make sense? So the meaning of activity is a single discrete step, work step in the total project. So the project has different activities. If you look to the steps of construction project planning, the first step, which is the most important one, we have to list all activities that we need to perform. If you look to these pictures, to construct this project, you will find different activities, starting from excavation, foundation, columns, framing, masonry work, sheathing, exterior finish, interior finish, landscaping. So all of these are different activities. So we have to list all possible activities in your project. Then you have to consider, you have to determine how these activities are going to be performed. And the most important part also, what is the sequential order in which it will be performed? What is the logic relationship? Which one is first? Which one is second? Which one is third? Can we do them concurrent? Or we have to wait until we finish this activity to start the next activity? Estimating activity durations. This one is very important to figure out the final duration of the project. What is the planning technique that will be used? We have different planning techniques. The first one is called bar chart that will be covered today. And we have one more, network models in terms of activity on arrow or activity on node, will be discussed later. So let's start with the first planning technique, which is called bar chart. Bar chart, we are going to construct a diagram. The vertical axis represents the activities in your project. We have different activity. For this example, we have planning, research, design, implementation, follow-up. And the horizontal axis represented the time frame. This time can be in days, in weeks, in months, in years, whatever the unit of this time, based on what is the duration of each activity. That makes sense? Then I will represent each activity, for example, planning, with a bar like this one. This bar is starting from here until here based on the duration of this activity. So each activity is presented by a bar that presents the activity duration. And then, for example, design activity will be represented by a bar. The independency between these activities is shown here. So the end of activity of planning, I have to start the second activity of design. That makes sense? So dependency between activities can be presented by vertical lines. This vertical line represented the dependency between activities. This bar chart usually used to communicate with lower level between workers, laborers, supervisors. It's not common, it's not professional, but can be used. Present part of the overall program, useful for resource management. We have some examples how to construct the bar chart, and I will go through them. But before this, we need to define some dependency between activities. If you look to this chart, in a very simple way, the end of activity A means the start of activity C. How can we describe these dependency, this logic relationship? We have different ways. All of them will deliver the same meaning. We can say activity C depends on activity A. That means we have to finish activity A first to start activity C. We can say activity A precedes activity C. We can say activity A is a predecessor of activity C. Activity C succeeds activity A, or activity C is a successor of activity A. All of these expressions means the same meaning, which is we have to finish first activity A to start activity C. Then this vertical line represents the end of activity A and the start of activity C. That makes sense? So be careful about these two expressions. Predecessor means the before, the activity that should be done before. And the successor is the activity that should be done after. That makes sense? First example, we have 9 different activities in one of the projects. Suppose that a site preparation and the concrete slab foundation construction project consists of 9 different activities. I will label these activities by one letter. So we have activity A, B, C, D, E, F, G, H, I. And this is the description of each activity. For example, activity A means site clearing of brush and minor debris. And this activity will will continue for 2 weeks. I have another activity, for example, B. Activity B is removal of trees. And this activity will last for 1 week. And so on. Activity C, general excavation, 2 weeks. Activity D, grading general area, 1 week. Activity E, excavation for utility trenches will need 2 weeks, and so on. So keep in your mind the first steps, or the first step to construct the project or to start construction project planning. We have to list all activities we have, and I am done. We have a project, and these are the required activities: A, B, C, D, E, F, G, H, I, 9 activities. And the duration of each activity is already determined based on the construction estimating and the productivity and the available crews that will be perform the work. Then we need also to figure out the logic relationship between these activities. For example, I cannot start general excavation, activity C. I cannot start the project with activity C before A. We have first to clear the site. We have first to remove the trees. Then we can start excavation. This is called logic relationship. These logic relationships or these independency is defined here in this table. So I have each activity. What is the description of each activity? What is the duration of each activity? And what is or what are the predecessors for this activity? So if you look to this table, looks like I can start the project with activity A and B at the same time at the beginning of the project because we don't have any predecessors. There is no activity that must be done before starting A and B. That makes sense? But when you start activity C, we have to finish first activity A because activity A is a predecessor for C. And is the same for D. The predecessor for activity D is A. So I have to finish A first to start D. Activity E, I have to finish B and C first to start E because B and C are predecessor for E and so on. So the logic relationships are given, the duration of each activity is given, and what is the name of each activity. So we need to use these details in this table to construct the bar chart. And finally, the bar chart will help you to figure out the total duration of the project when this project will be done. So let's start first to construct the bar chart. I will draw a vertical line or a vertical axis. This vertical axis will represent the activities. And a horizontal line, the horizontal line will represent the time or the duration of each activity. Looks like from this table, this duration in weeks. So the unit of time that will be used in this chart will be in weeks. So I can say this is week number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14, and so on. So the first activity that we can start the project will be activity A. We don't have any predecessors. And the duration of this activity is 2 weeks. So I will come here and construct this bar chart for 2 weeks, and I will label it A. This is the first activity starting from 0 at the beginning day, at the beginning of the project, and will last for 2 weeks. Also, I can start the project with activity B because we don't have any predecessor and the duration of this activity is 1 week. So I can put here activity B 1 week and starting from 0. Then activity C can be started after you finish activity A because A is a predecessor and we have a duration for this activity 2 weeks. So by the end of activity A, I can start here activity C for 2 weeks. This is C. That makes sense? Also for activity D, I cannot start D until you finish A for 1 week. So by the end of activity A, I can start here D for 1 week only. We can change the color here. Activity E has a duration 2, and we have to finish B and C. B and C. Keep in your mind. It's 2 weeks, B and C. So B will be done here. C will be done here. So I have to start activity E from here for 2 weeks. This is E. So guys, keep in your mind, activity E has a 2 predecessors, B and C. So B must be done. C must be done to start E. So B is already done here. I'm good. C is already done here, so I can start from here, activity E for 2 weeks. That makes sense? Then activity F has a 2 predecessor, B and C, for 1 week. B is done here, C is done here, so I can start F for 1 week here. This is F. 1 week. For G, we have 2 predecessors, D and E, for 1 week. D and E. D is already done here. E is already done here, so I can start here 1 week for activity G. H has a 2 predecessor, D and E, for 2 weeks. D is already done here. E is already done here. So I can start from here 2 weeks for activity H. That makes sense? So the end of activity D, the end of activity E, I can start H. So we have to wait. D is already done, too early. Then E is already done here, so I can start from here, activity H. The last activity is activity I, pouring concrete. I have to, we have 2 predecessors, F and G, so I have to wait until F is done. F is done here. And G is done here. So I can start from here, activity I, for 3 weeks. That makes sense? So F and G are predecessor for I. So F is already done too early. G is already done here. So I can start from here, activity I, for 3 weeks. Nothing else. So I am done with the bar chart. If you look to this chart, you can read some information. This is activity A, B, C, D, E, F, G, H, I. If you look to the last activity in this chart, can tell you what is the total duration of the project. This project will be done in 10 weeks. By the end of the last activity I can tell you this is the final duration of the project, which is 10 weeks. Does that make sense? We can read also the critical activities. The critical activities that will be A, C, E, G, and I. So critical activity or critical path, which define critical activities, will be A, C, E, G, and I. We will define this critical path later, but right now, the activities that coming in sequence. So if you finish A, I can start C, I can start E, I can start G, I can start I to the end of the project. These activities are called critical activities. And this path of the project is called critical path. We will talk about this later in more details. So this is example number 1. Let's go to another example, example number 2. We are going to construct the bar chart and to figure out the final total duration of the project. We are given many activities, A, B, C, D, E, F to M, and what is the duration of each activity, and what are the followed activity. For example, A can be followed by B and C. So I have to finish A first, then I can start B and C. That makes sense? So to construct this bar chart, I will draw vertical axis, represent the different activities, and the horizontal axis represent the duration or the time of each activity in weeks. Looks like the unit here is given, I think, I'm sorry, days, not weeks. So I have to change this one to be in days. So I can label it based on the given duration. We have huge number 11, 3, 6, 4, 6. So I can 2 days, 4 days, 6 days, 8. I think we have odd numbers, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It will not do, so I will label it by 2, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. Let's see. So I will start the project with activity A with a duration equal 3 days. So activity A will last for 3 days. Keep in your mind between 2 and 4, we have here 3. So this is activity A. This activity A is following by activity B and C. So B with the duration 3. So I can put here B with the duration 3. And also followed by activity C with the duration 5. 5 means this. This is activity C. So by the end of activity A at day number 3, I can start activity B for 3 days. I can start activity C for 5 days. That makes sense? Then, so I am done with B and C. Keep in your mind, activity B has 2 following activities, D and E. So activity D has 4 days. So by the end of activity B, I can start activity D for 4 days. This is D. And also activity E for 5 days. So by the end of activity B, I can start E for 5 days. So by the end of activity B, I can start E for 5 days. So 5 days means here. This is activity E. Does that make sense? Following to activity C, we have activity F for 3 days. So by the end of activity C, I have activity F for 3 days. This is F. Okay. The next is activity, the following for activity D is H. And H has 3 days. So by the end of D, I can start H because activity H is following to activity D. And the duration of activity H is 3 days. So by the end of D, I can start H here for 3 days. This is H. For E, by the end of activity E, I can start K for 3 days. So by the end of E, I can start K for 3 days. Where is E? Here is E. I can start here for 3 days. This is activity K. This is activity K. For F, activity F is followed by K and D. Activity F is followed by K. We are done. This is F followed by K and G. The duration of G is 6 days. So by the end of F, I can start G. By the end of F, I can start G here for 6 days. 2, 4, 6. This is activity G. Six days. The duration of this activity, 6 days. By the end of activity H, I can start I and J. I is 2 days, J is 11. Let's start with I. I is 2 days. So by the end of H, I can start I for 2 days. Whereas H, I can start I for 2 days only. This is I. At the same time, by the end of H, I can start J for 11 days. So by the end of H, I can start J for 11 days. 2, 4, 6, 8, 10. This is called J. By the end of H. Activity K is already done. We don't have any following. Activity G is already done. We don't have any following. Activity I is already done. We don't have any following. For activity J, which is 11 days, by the end of activity J, we have M following. The duration of M is 6. So here I can start, by the end of activity J, I can start M, which is following to J with 6 days. This is M. And the activity M does not have any following activity. So by the end, I constructed the bar chart. And this is the final duration of your project which is 24, 26, 28, 30. So the final duration of the project is 30 days. This is the final duration of the project. And this is called bar chart. Keep in your mind, we have here critical path. I can say A, then B, then D, then H, then J, then M. So the critical path will be A to B to D to H to J, then to M. And these activities are called critical activities. Just a hint, we will define this in more details later, but the end of A, I have to start B, by the end of B, start D, by the end of D, I start H, by the end of H, I start J, by the end of J, I start M, by the end of M, I reach it to the final duration of the project. One more example. For the given project activities, we have activity A, B, C, D until K. The duration of each activity is given in weeks. And what are the following activities? We need to construct the bar chart to figure out the final duration of the project. To construct your bar chart, I will draw the vertical axis, which represent the different activities, and the horizontal axis, which represent the duration of each activity. And the unit for this one will be in weeks. I think I can make these activities the duration also 2, 4, 6, 8, 10, 12, 14, 16, 18. You have to select the perfect scale, 20 weeks, 22, 24, and so on. Let's start with the first activity, which is activity A. This is the first one, following by B, C, D. So I will start with A with 2 weeks length. A has duration equal 2 weeks. And this activity is followed by B with the duration 3. And A is followed by C with the duration 6. And A is followed also by D with the duration 7. So by the end of A, we have following B, C, and D. And the duration of each activity is different. Keep in your mind, activity B is followed by activity G. The duration of activity G equal 3. So by the end of B, I can start here G for 3 weeks. Activity C is followed by E. The duration of E is 3 weeks. So the end of C, I can start E. The end of C, I can start E for 3 weeks. By the end of D, I can start F for 2 weeks. By the end of D, I can start F for 2 weeks only. By the end of G, the following one is L with 1 week. So by the end of G, I can start L for 1 week. By the end of G, I can start L for 1 week only. This is L. Dependent or following G. The end of activity E, we have a following I with a duration 3. So E, I for 3 weeks. This is I. Activity F is followed by J with a duration equal 3. F followed by J for 3 weeks. L is followed by M with a duration equal 5. L is followed by L is followed by M for duration equal 5. L is followed by, I'm sorry, LM5. So L is followed by M for 5. This is M. After I, we have K for 6. After I, we have K for 6 weeks. This is K. After J, we have K. After J, we have K. That's fine. That's fine. After M, we have K. After M, we have K. That's fine. K, we don't have any following, so K will be the last activity in the project. So by the end of activity K, I can tell you the total duration of the project equal 20 weeks. I can finish up this project in 20 weeks. And also I can tell you what is the critical path. I can start with A, then probably we have different critical paths here, but we can say we have A, D, F, I, K. So the critical path will be, I will start with A, D, F, I, K. And these activities are called critical activities. We will discuss this later in the next video. Bar chart has some disadvantage. And this is the reason why bar chart is not common in the professional level. Does not give you the ability to visualize the exact progress of the project. suitable only for a small number of activities. Imagine we have many activities, 20, 100, 200 activities. It will be horrible to construct this bar chart. Does not show a detailed sequence of activities. We have more logic relationships. We will discuss this in more details later in the next video and the next one. Does not show critical activities. I can figure out the critical activities, but it's not clear enough why these are critical activities. Does that make sense? Does not show the precise effect of a delay, if we have a delay between activities, or failure to complete an activity on time. So all of these disadvantages will encourage us to discuss more planning techniques, which are activity on arrows and activity on nodes that will be discussed in the following videos. Thank you so much and see you later.